Welcome to the second installment of our two-part Introduction to the Arduino. In the first lesson, we explored the Arduino hardware and related capabilities. Now we'll explore the Arduino software package. To begin, head over to the Arduino homepage at www.arduino.cc and click on the Software tab. Scroll down to the Download the Arduino IDE section and go ahead and download and install the Arduino Integrated Development Environment. This is a software program that we'll be using to write and compile our code and transfer the code to our Arduino Uno. Once you've downloaded and installed the Arduino software package, open up the program and you should see a new sketch appear just like this. And the sketch has two functions, setup and loop. Right? Functions are a way of modularizing your code in software, and each function here has different inputs. So loop has inputs here, setup has inputs here, and in fact currently setup and loop have no inputs, so they actually don't take any inputs. And then each function returns something as well. So right now setup is listed as void, so it actually doesn't return anything, and loop is set up as a void as well, so it's not actually returning anything. So we have setup and loop, and these are two functions required for every Arduino program, and the Arduino programs that we're writing are referred to as sketches. So in the setup function here, you'll place all the code that will only run one time. So this might include setting pin modes, defining various inputs or outputs, or initializing parameters such as the serial ports. The loop function, on the other hand, is going to contain your code that will continually repeat. So anytime power is applied to the Arduino, the loop will continue over and over and over again. A few interesting attributes to draw your attention to at this point. Each function has curly brackets here defining the beginning and end of the function. And you'll notice if I select one or the other other bracket is highlighted. That makes it convenient in terms of identifying the begin and end points of your function, particularly when you have large amounts of code. You'll notice these dual forward slashes here. These are defining a single line comment, right? So you can put any information here to help identify parts of your code or even help with debugging, and the compiler will essentially skip these lines. And you can also have multi-line comments as well. So if I come up to the top here and I enter a forward slash and an asterisk, if I hit the enter key, you'll see it automatically closes this multi-line comment here now. And that's really a function of the Arduino IDE itself. But from here, I can put some descriptive information. Maybe I put my name, and let's hit enter and put the course. And we'll just continue with any pertinent information you may want to list here. And again, the compiler will effectively skip all of these lines when compiling your code, right? This is a multi-line comment here. And even with this simple code, we can compile the code and upload it to our Arduino. So the first thing you want to do is go to Tools and make sure you have the proper Arduino board selected. Here I'm working with the Arduino Uno, so I have the Arduino Uno board selected. Second, make sure you have the proper communication port selected. So for me, it's COM3. This is a USB port for me. So now I have the proper board selected, and I can communicate with the board as well. And to compile our sketch here, we'll go ahead and click the check mark, the verify button. It'll turn yellow as it's being compiled. Right? And the compiler then is taking this relatively abstract code that we've written. To you and me, it may look relatively straightforward, but to the Arduino microcontroller, it's abstract. And compiling that code, that information down, ultimately to the machine code, the zeros and ones, that the microcontroller will then use to perform the particular task. And you'll also notice down at the bottom of the IDE that the IDE is telling us how much of the program memory our sketch has used. So here, my sketches use about 450 bytes of the roughly 32 kilobytes available. So I'm using really 1% of the available storage space. Now, all this is telling me at this point is that I've finished compiling my sketch with no compiling errors. I haven't actually uploaded my code to the Arduino yet. But you'll notice there were no compile time errors here. Compile time error would be, say, maybe using the improper syntax. So let's say in my setup function, I left out my end bracket here. If I try and compile that, you'll notice I get a compile time error here, right? So it says I'm effectively missing the end bracket to my beginning bracket here. So if I go back and put that end bracket in place and recompile, I will find no compile time errors on my updated sketch here. With our code successfully compiled, we can go ahead and upload the code to our Arduino via the upload button here. And you'll notice the code is being uploaded to our Arduino, and it's done uploading here with no issues. But let's make our Arduino do something a little more interesting. So one page I'd like you to refer to throughout the semester, if you head back to the Arduino homepage, arduino.cc, head over to Learning, and then click on the Reference tab here. So throughout the course, you'll find the Arduino language reference page to be a very useful repository of information here. And you'll notice the various links to some of the functions. Here's your overall structure functions, your setup and your loop, information on various variables. Here you have constants high and low. That's a 5 volt, 0 volt, 1 or a 0. And then various functions that you'll be using with your Arduino, such as pin mode, setting the mode of a pin to output or input, working with digital writes and digital reads, and various other information. So there's really a wealth of information here, and it's worthwhile actually just bookmarking this website for use throughout the semester. As an example then, let's turn on our LED from the preceding lesson, but instead of using the 5 volt supply on the Arduino board, let's use a digital input output here. So let's take a look at the digital input output functions. We have pin mode, digital write, digital read. Let's go ahead and click on pin mode here. And you can take a look at some of the syntax that we'll need to perform this task. So we'll be setting a pin on our Arduino, say pin 4, and then the mode here will be setting it as an output that will engage that pin to allow us to output 5 volts. And you have some nice example code that you could work with for both your labs, your homeworks, and ultimately your project here as well. And then we'll also need a digital write in our sketch so that we can actually send that pin high or low. So here, high and low in capital letters are going to be constants here relating to, say, 5 volts and 0 volts. So we'll need a digital write in our loop function, and that'll need a pin. So we'll say pin 4. And then a value. So if we wanted to turn on the LED, we'd write this value high. If we wanted to turn it off, we'd write it low. And you'll notice again some nice example code for you to dive into, look at some of the syntax, and again utilize that for the course. If we go back to our sketch then, let's dive into our setup function here. And we, since we're going to be turning our LED off and on with a particular pin, we'll need to define then a pin mode. And let's select pin 4 in this case. And we're going to set that as an output pin. And that's going to allow me to send 5 volts to that pin as a digital output here. Of course, this bit of code alone won't actually do anything interesting here, right? This is just defining a parameter. This is setting a configuration for my Arduino in terms of operation here. If I want to do something interesting, I need to go down to the loop and define the code that will actually perform that task. So let's go ahead and give it a digital write. And we'll use pin 4 here, and we'll set that high. Okay. So anytime now I run my code, once I compile it and upload it to my Arduino, I will have set the pin 4 as an output, and anytime power is applied to the Arduino, then I'll be writing that pin high. I'll be supplying 5 volts to that pin, which I can then use to turn on my LED. So let's go ahead and compile this. Make sure there's no errors here. Okay, that's great. So my sketch has successfully compiled. There's no errors, and you'll notice now I'm using about 2% of the available program memory here, so no worries there. Now, just to reiterate this notion of compile time errors, let's say, for example, after my digital write, I forgot my semicolon here, right? Semicolon is an indication that the code you're writing on that line has ended. So when the compiler goes through, it knows to go to the next line. So if I were to attempt to compile this sketch now, you'll notice, right? The code was expecting the compiler was expecting a semicolon, and the next thing it found was a curly bracket, right? So we have to go back in then and add in our semicolon, indicating the end of that line, and I can go ahead and compile that code, and now I've recompiled with no errors. So lastly, then we can go ahead and upload our sketch to the Arduino. You'll see it's uploading, and we're finished uploading with no errors there. So here's my circuit then with the Arduino Uno, the solderless breadboard, the LED and current limiting resistor. And unlike the previous lesson, instead of supplying power to my LED through the 5 volts coming off the board, I'm now using a digital input-output pin to supply power to the LED. Unfortunately, however, my LED is not illuminated at this point. And I've sort of rigged the circuit this way to try and highlight this, what's called a runtime error. Now, the compile time errors can be relatively easy to catch. Often the Arduino IDE will actually highlight them for you, as we just saw. Runtime errors, however, can be more challenging to debug, right? So if you look at my circuit a little more closely, you'll notice that the power being supplied to the LED here is connected to pin 3. However, in my code, I define that as pin 4, right? So we need to address this runtime error. So first thing we're going to do, let's go ahead and remove power so we don't risk damaging the circuit. Okay, since I defined pin 4 as my output pin, let's go ahead and switch the pin here. And then we'll resupply power to my circuit. Okay, with power resupplied, you notice the LED is now running again, right? So this is an example of a runtime error. And finally, let's talk about functions, which are a great way to modularize your code and ultimately make it easier to test. So for example, let's say I wanted to create my own function that would turn on an LED. Now, admittedly, I could do this with a digital write in the void loop, but let's say I wanted to create my own function here. So I'll start by typing void. This is a function that will not actually return anything, and I'll call it turn on LED. Now, we said we need input arguments, so we'll input an integer that we'll call pin, and we'll be defining that here in just a moment. And then any function needs beginning and ending curly braces, right? So if I enter a left curly brace and hit enter, it'll automatically close for me. Now I'm going to use my digital I/O again, so I'm going to use my digital write. And instead of assigning it a specific number such as 4, we're going to use the more generic integer pin here. And I'm going to write that high. I'm going to go ahead and apply 5 volts to that pin. And so let's go ahead and compile this code. Great, no compile time errors, and we can go ahead and upload this new code to our Arduino. And we see we've successfully turned on our LED using our turn on LED function that we created.